For each atom, draw the energy diagram or orbital diagram. Let's just go back and forth and then write its electron configuration. So for carbon, if you look on your periodic table, it's number 6. So let's draw the energy diagram for that. We have energy going up on this diagram. You can imagine this being the nucleus down there with 6 protons. In a neutral carbon atom, we're going to also have 6 electrons. Got 2 electrons in the first orbital, and 1s. And then a little bit up there on that energy diagram is going to be your 2s orbital. And for atoms that have more than 1 electron, the 2p orbitals are going to cost a little bit more to be in. And there are 3p orbitals. If you follow Hund's rule, you're going to fill them spinning parallel and unpaired. We want to maximize the number of unpaired electrons. So there is the energy diagram for carbon, and let's write that in electron configuration form. Is going to be 1s orbital having 2 electrons, 2s orbital having 2 electrons, and then the 2p sublevel, that whole set there, is going to have 2 electrons. And turning this into noble gas notation is the previous noble gas is helium. Put that in brackets. And then the remaining electrons are going to be your valence electrons, is 2s2 and 2p2. This is all for carbon. Let's move on to argon, is the noble gas, number 18. So let's go with the orbital notation for this one. Argon, number 18. And the first orbital is going to be your 1s orbital. Your second one is going to be your 2s orbital. And then in the second energy level, we have 3 p orbitals. They're called your 2p sublevels. And follow Hund's rule. Let's fill them unpaired until we have to. And we're at 10 electrons, so we need to keep going. 3s is the next available orbital. And then the 3p, there's 3 of them. And we're going to fill all of that up, and we'll get to 18. So the electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p6. And it's a noble gas, so just gets that. Now, let me pause here and copy a periodic table over. Be right back. You also, if we use this periodic table that's labeled with the blocks, argon is over here. And so we know that the electron configuration is going to end at the end of the 3p block. Right, there's 3p1, 3p2, 3p3, 3p4, 3p5, and argon is going to be 3p6. So that's how we know we're going to stop there. And if you need help with the filling order and you're not familiar with this periodic table, the way that fills, then we're going to give you this Aufbau filling chart on your reference sheet. So you just follow the arrow. You know the lowest orbital available is 1s, followed by 2s and 2p, 3s, 3p. But now here, we don't go to 3d. These are available in the third energy level, but it's going to cost a little less energy to be in the 4s, so that's going to fill first generally. Now, Aufbau rule does get broken pretty frequently, but on your test, that's the way we want you to go, unless there's yeah. All right, so the last one here is going to be nickel. So let's do that here, nickel. Do that here in green. All right, so nickel, find that on the periodic table, and that's going to be right next to iron and cobalt. 28. Back to the energy diagram. Let's do that. All right, so we're going to show you this using this filling chart now. So there's 1s. We're going to, you know, we start at 1s. All right, Pauli's rule says 2 electrons in each orbital max, spinning opposite ways. Right, 2s is next. Right, the spacing is not going to be drawn on the scale here. And then the 2p, 1, 2, 3. Right, so we're over here. Right, keep going, you get 3s. 1 there. And after 3s to 3p. Now, if the 3p is not 3D, go to 4s. And after 4s, we go to 3D, and we're going to stop here once we get to. Now, I have not been counting these arrows, but I know nickel is the 8th element in that block, so I know I'm going to need to go to 3D. Right, 1, 2, 3, 4, 5. Wow, barely fit that in. 1, 2, 3, 4, 5, 6, 7, 8. Right, so I know that's my energy diagram. And again, if you're like, well, how did you do that so fast? If you look on your periodic table, nickel is right there. So that tells me I need to get my electron configuration needs to end at 3d8 because it's the 8th element in that 3D block. Writing the electron configuration for all of this is going to be 1s2, 2s2, 2p6. Let's see, I got 2 more minutes here. 3s2, 3p6, 4s2. So just follow these arrows is what you can do if you don't have this 4s, and then you go back to 3D. Okay, 3d10. Oh, 3d8 is where we're gonna. Sorry, we're not gonna fill that out. Just said that. Right. So 3d has your 8 electrons. Now some teachers ask you to rearrange these and put the 3s together. That's not a big deal for me, so you can leave it like that. And then now finally, let's get this in the noble gas formation. All right, so the noble gas right before that is going to be argon. All of that is argon. That's the first 8 electrons. If you need to count them, you can. That's 2, 4, 10, 12, 18. So that's argon. And then whatever is left is what you write. 4s2 and 3d8. Noble gas notation.